I guess that we can start. So, good morning, everybody, and welcome to this webinar today. Many thanks for joining this. And this webinar is organized jointly with the European Space Agency and WOLL Europe. From our perspective, from the perspective of WOLL Europe, this session is really timely. It's absolutely important because, as you know, I mean, the water sector is increasingly confronted with a lot of complexities. We have, I mean, the climate pressure, the climate change pressure, water scarcity, contamination, and competing uses of water that really needs us, I mean, to promote, to foster as much as we can from innovation to real implementation. Otherwise, I mean, innovation will remain on a decorative status. In this context, the contribution of space-based data and services, it is not just, I mean, an added value. It is really the enabler, is one of the enablers for decision-making, efficient decision-making, monitoring, and scaling up of solutions. WOLL Europe and ESA, and I'm very glad, I mean, to see Beatrice Barresi with us today. And WOLL Europe and ESA signed a Memorandum of Understanding recently in order to enhance the collaboration and to allow members of WOLL Europe, stakeholders of ESA, and the water community at large, to take advantage of the opportunities given by both organizations in terms of programs, support, I mean, really at large. So we really see this exchange because it will be also an exchange to better connect the communities. I remember also in the Water and Energy Labs, for which this webinar is also addressed in order to support territories in taking advantage from data management from space observation, and also to align, I mean, what we can do in terms of perspective and explore the practical pathways for the collaboration between water and the space ecosystems. So having said that, I'm really happy, I mean, to hand over to Beatrice Barresi, to ESA, the floor and start the discussion. Thank you so much.
Thank you. Thanks a lot, and welcome also on my behalf. I can just echo the word that Andrea said. We are also very glad to have signed this Memorandum of Understanding with Water Europe, because it really gives a tangible element of the alignment of intention between the two organizations. But we want that this memorandum becomes operational. It's, let's say, brings factual benefits to all the community. So the webinar of today, of course, is just the first step, the first element of this path of collaboration. You will hear more what's coming, because we have been quite active in the past month to draw together a roadmap to decide what we want to do together. So stay tuned, please follow this webinar, and you will hear about all the opportunities and all the initiatives that we have organized together.
Many thanks, Beatrice. Let's give, I mean, a quick overview of the webinar today with the agenda. So welcome introduction from European Space Agency and WOLL Europe. Then we have the first contribution is from Roberto Di Bernardo from the expert group of WOLL Europe on DSS. Then we have, I mean, from the same expert group, we pass from the digital water management systems to design a local digital twin for urban water systems, the experiment and the experience of Cyprus from Demetrius Eliades. And then from observation to action, there will be a presentation by Ivana Barazin, the CEO of Terremotus, about decision intelligence across soil, water, and industry. And then there will be an important space dedicated to the European Space Agency's BUS program that will be presented by Beatrice Barresi. And then there will be time for question and answer, for discussion, and wrapping up the session. So, I mean, I would like, I mean, to invite Roberto Di Bernardo to take the floor and start his presentation. Thank you, Roberto.
Thank you. Thank you, Andrea. Thank you, Beatrice, and thank you, the European Space Agency and Water Europe for the organization of this webinar and having me as a speaker. This is Roberto Di Bernardo. I am the head of Grant Office at Engineering, that is a multinational group focused on the digital technology, supporting the customer in the digital transformation. I am also honored to represent, in this case, the Digital Water System Management expert group within Water Europe. Here, briefly, the agenda of my presentation. I'm talking about introducing the mission, one of the key mission of Water Europe, then going deeper into the mission, the objective, and the activities of the expert group, and then some of the key activities, key project that was built within the Water Europe ecosystem. Briefly, the mission, that one of the key mission in the Water Europe is to support, implement a water smart society. So a society that have at the center the value of water, increasing the value of water. How to implement this in several activities. So boosting the resilience in the water system, in particular concern, it was mentioned by Andrea, the impact of climate change, but even the human pressure in using water. In this sense, it's important to have closer loops in the water in general, resource usage, so boosting circularity and properly manage the water resource, in particular against problem related to water resource scarcity and increasing of pollution. Here is important to have the involvement of the key stakeholder, because only in this way there is the opportunity, the possibility to have a better water system governance. To implement this mission, there are several ingredients. As you can see in the right part of the schema, in the bottom part of the schema, there is the digitalization of water systems. And here it's where the expert groups come to action. These are the main mission and the key objective from a research perspective of the Digital Water System Management expert group. So the focus is to boost the adoption of digital tools and platform in the water sector to improve the system's operations, but even to increase the general decision-making process involving all the key stakeholders in the water sector. As a key objective from the research perspective, we are talking about an analytics, modeling, decision support system, and in general to promote digital tools and platform, standardized methodology, and boost on interoperability to leverage the amount of data that can be used. And today's the data, the satellite, the space data related are one of the most important resources, data resources that in our project we are leveraging on. The key technology we have been focused on are mainly at the moment the data digital twin and data spaces that are key, let's say, technologies at the moment in the Europe agenda. In terms of current activities, during this period, we have been working together with the other experts of the group, collecting use cases from current or just ended project concerning the use of digital twin, data spaces, or the connection of the two. In particular, here are some relevant topics we have analyzed in this collection that use satellite data are the prediction of water quality management in reservoirs for then water treatment plants, the water distribution planning optimization, in particular when we talk about land use, and leakage detection, water loss in prevention and water networks. Of course, within the Water Europe, the collaboration in between members is pushed more and more. One of the areas in which members are quite active and are, let's say, put on field the ideas and to implementing the mission of the group is through European funded project. So several proposals have been defined in within the umbrella of Water Europe, and the two projects I'm presenting today came from this ecosystem. In particular, I'm talking about Waterverse and ideation. So going in presenting briefly Waterverse project, Waterverse was funded under the data under a data topic, data 0103. It's a cluster 4 topic. What's is the general information about the project? What's the main aim of Waterverse was to push within the water sector for better data management. So increasing the capability in terms of data management, producing tools that would allow data management in the water sector more accessible, affordable, secure, and fair. The main objective was to release tools for data management in the water sector that have been validated through 6 real-world pilot cases. The distribution in terms of geographical coverage was include almost all Europe, because we move from Cyprus to UK, from Spain to Finland, passing through Germany and the Netherlands. Of course, these 6 use cases allow us to collect from the real needs of stakeholders what should have been done in terms of improving the data management. The result, I'm talking now about the results because the project just ended end of 2025. The key result was the release of the water data management ecosystem, that is a set of different tools that can be used according to the needs of and according to the cases for data in general, data management, collection, discovery, harmonization, and processing. It's important to say that the work that have been done within Waterverse was to, in the end, increase the overall quality, or put the stakeholder in a condition to increase the quality of data they managed in order to reduce cost in their operation, enable possibly new use cases, but also as a starting point for the implementation of future water data spaces, where the quality of data is an essential part for the sharing of data towards different third parties or among different stakeholders and players. This is an example from one of the pilot of Waterverse. It's a pilot implemented in the Netherlands, and the goal is prediction of water quality and its impact in the treatment step. The key stakeholder was PWN, public drinking water utility that supply over 800,000 customers in the north of Holland. The focus was to increase the quality of data, in particular, standardize the data coming from multiple sources, improving the data accessibility, reducing reliance on raw file sharing, and of course, reducing cost due to manual data processing. Moving to the second project, ideation project, it was funded under the Mission Ocean work program, and it's the overall the main aim, of course, is to provide let's say pave the way for providing new tools for the improvement and protection of inland water. In particular, there are several action currently at European level, wide action like Destination Earth, but also the digital twin ocean. The key point here for this topic was to put aside of the ocean, include another important part of water in our planet, that are the inland water, that have immediate direct impact on life and human being. In particular, this is a CSA, so it's a coordination supporting action, that the main aim is to pave the way for the implementation, for the future implementation of digital twin for inland waters that has to be interoperable with the digital twin ocean. The project was based, it's currently still an ongoing project. It's going to be in the mid of this year. It was built around a methodological framework with several steps. The first step was, of course, the engagement of stakeholders. In particular, it was built on, where available, following the approach of Water Europe and leveraging the ecosystem on water-oriented living lab. In this case, we managed to collect more than 500 stakeholders. The next step was, or almost in parallel, was to create a knowledge-based concerning project, research, policies, all about inland water and digital twin. And then we perform a gap analysis in order to understand, in between requirements collected and the state of the art, what is missing concerning the future implementation of digital twin in inland water. Then, as final result of this project, there is the definition of a reference in architecture for the digital twin, the future digital twin, and a roadmap for their implementation, having in mind the integration and interoperability with the digital twin ocean. So, as already mentioned, the key here, the key output of the project would be the reference as key output, or the reference architecture on one side. This is just a picture of version 1. We are working on version 2, and OpenKeywAS, that is the knowledge base of the project. And in this case, it's good to mention that since the resources collected went far beyond the expectation, because at the beginning, the idea was to collect around 100 resources of knowledge. Now the project collected in total over than 7,000 resources in terms of policy project papers, research papers, etc. So we include in this solution in OpenKeywas also large language modeling capabilities to improve the interaction with the users and let them move and search and find results in this big amount of knowledge collected. Even in terms of output, the project defined the reference use case that was useful to define requirements for the overall project. In particular, in this case, the urban reference use case that was implemented or defined in Spain, not implemented, sorry, it was defined in Spain, where the key actors was the Aguas de Barcelona, where it's clear the complexity here managed in terms of different system implies so water treatment plant, wastewater treatment plant, water climate processing, in order to optimize the overall process against the scarcity of resources from local rivers or aquifer, etc., and reuse part of this water, the reclaimed water, for the other purpose like irrigation or injection against salt intrusion. Here, the digital twin can help in terms of predict short-term future water availability, what-if scenarios, and general optimization in decision-making. Regarding the other reference use case mentioned in another reference use case is the wetland that was defined in Greece, in particular as a key stakeholder. We have the Greek Biotope and Wetland Center. Here, against looking at inland water, on one side, we talked about the inland water that affect the urban area. Here, we are talking about the impact on potentially local ecosystem, biodiversity, etc. In this case, the digital twin are used in order to optimize and to support the key stakeholder in monitoring and take decision of the overall ecosystem, the impact of human activities in the environment, and so let's say support a better management in the overall water use in the for the ecosystem. In this case, it was important, of course, the public awareness and the education in the concerning the water as resources. To close, this is a picture of the leadership team of the expert group. Lodisa Vargiu from Setaqua is the leader of the expert group, and Dimitris Eliades from Kios, together with me, are the co-leader of the group. With this, here you will find all the contacts to reach us out. Many thanks. This is all from my side.
Thank you very much, Roberto, for the insightful presentation and for the detailed explanations of our ideation project. I will now give the floor to Dimitris Eliades, who will provide us an explanation and an overview of the deployment of digital twins for urban water and wastewater system within the Cyprus context.
Thank you. Roberto, you need to stop sharing for me to share.
And I also take the chance to let the audience know if you have any question, you can use the chat and we will answer and go through them during the Q&A session at the end of the webinar.
Okay, so can I start? Yes.
Yeah, sure.
So good morning, everybody. It's really exciting. It's an exciting opportunity to be here and present with Water Europe and ESA. The title of the talk is Designing Local Digital Twins for Urban Water Systems, and this is a Cyprus experience. This is essentially a nice build-up with what Roberto showed. My name is Dimitris Iliadis. I have been together with the expert group on digital water systems management, but I'm also an assistant professor at the GEO Center of Excellence at the University of Cyprus. So, presentation in a nutshell, I will introduce the concept of digital twins, especially in the context of water systems, and explain our experience in building real digital twins in Cyprus, explain a bit also what's under the hood, and try to give a glimpse on the future. This is, of course, the accumulation of a lot of work that has been done, a lot of different projects, as well as with the insights that we have managed to collect at the Digital Water Systems group that already Roberto described. So first, let me start for the people who don't know what is a digital twin, and I always like to use the example. You all remember in April 1970, when Apollo 13 had an explosion, it affected its trajectory. So NASA had to continuously update a living model of the shuttle using real-time telemetry to analyze the crisis. And to do that, they had to reprogram multiple simulators to determine the new state of the system and find the optimal solution, which in the end enabled the astronauts' safe return to Earth. So this inspired the concept of digital twins. And essentially, digital twin is a virtual representation of a physical system and also its evolving state. And we do this using models and data. And these systems, they should be persistently linked with the physical system. So it's not just a simulator. The data and the models need to be synchronized continuously or periodically using sensors and operational data. And in cases when you don't have sensors, then use data estimation and data assimilation methods to infer those states. Essentially, digital twins enable us to better monitor the system, to do event diagnosis, to simulate and predict the behavior of the system across its life cycle. It also gives us the ability to create decision support tools to answer different what-if scenarios, to give us feedback, and even to control the physical system. So in the concept of water systems, this roughly translates to the following. We have, hopefully you can see my mouse here. Maybe let's just put this. Okay, so we have the water system, and the water system is monitored by sensors. These sensors feed the system models, and by extent, we have the estimation of the unknown states of the system, and all of these are used for control. And at the same time, we can use the models and the estimates for optimization. And using the human insight, we can have decision support here. And in the end, through controls and decision support, we affect the actuators, and in the end, the water system. This is a very generic architecture, and it allows us to answer different type of questions. For instance, what's the situation of the system in areas where we don't have sensors? How would this problem affect the system in the future? If there is a contamination event, what are the possible sources of it? And even how to optimize the system for better performance and for reducing leakages. Now, in Cyprus, we have been working on digital twins for quite some time now, so from theory to practice. And in fact, my group was contracted by the water authorities of Limassol and Larnaca, two of the major cities in Cyprus, to establish digital twins of their drinking and wastewater systems. This was associated with more than 20 million euros investment in smart meters and pressure sensors. And this is very critical. I'm going to explain this in a while. And we have delivered at the moment two solutions, the Oceanos digital twin and the Xenon digital twin. But in a nutshell, if I was to put a workflow of what we did, initially we used GIS to model the assets. We then translated those assets into hydraulic models. We then integrated sensor data from SCADA and IoT together. And we also optimally place in specific locations sensors to help us in the state estimation and model calibration. And based on all of this, having this calibrated real-time model of the system, we were able to design smart water apps for decision support. So let's dive into what we actually did. This is where we start. We start from a GIS model. You combine it with satellite data or geospatial data, whatever you have, to create models of the system, mathematical models, computational models. And by using algorithms and data, you can create the state estimates. Now, this is combined with, it's critical to have sensors in optimally placed locations, because in water systems, it's really impossible to know all the states everywhere. So what we did is that we identified, based on these models, what were the best locations to install pressure sensors. And we use this to have better calibrated models. And of course, you cannot just simply take some sensor data and plug them in. You need some advanced algorithms. And this is where you use these science-based state estimation algorithms. And the goal is to be able to match as much as possible the reality with what you observe in real time. So you combine data from SCADA, the inflows, the air pressures in the system. You have data loggers, and you have smart meters, and you combining those together with some smart algorithms, you are able to create this real-time model. Now, let's see now in practice what this means. So this is what you see now is the user point of view. The user, we design interfaces based on QGIS, but this is not limiting to QGIS, where you can select the type of the system, the area, the models that you have, the type of sensor data that you are using, and you're able to run simulations. That's one thing. But also you have these smart water apps, essentially everything we produce in projects, in research, it goes here, and you can actually build on top of this. At the same time, we're using the open data. So here we actually connect with a lot of geospatial data, satellite data. All of these are very critical when making decisions. So together, all of this information, this fusion information is critical for the operators. This is an example where we allow, it's an extension of the system. This is for flooding specifically. We allow managers to evaluate different operational scenarios, for instance, to assess the risk. For instance, here we say that if there is an increase in overflow in an upstream reservoir, and this is, and on the right, you can see the water levels here. You can see the water levels. If we artificially create some rainfall, you know, which area of the city will be flooded, and the red parts essentially are the flooded areas. It also gives us which water infrastructure is going to be affected. And this allows us to assess the risk, etc. Or we can study what is the impact of some new developments. There is a new park, there is a new complex of building being built in some area. What would be the impact on the pressures of the system? What would be the risk of the people, you know, which people will not have sufficient pressure? And you can see here that if there is a big investment here, this could affect this part here. So this allows us for better, fair response to city planning. This was for drinking water, but for wastewater again, we have done something similar using meteorological data. Another type of data you can assess the flows in the wastewater system, and you can infer if there was an illegal dumping of wastewater into the system, or if there is an increase, if there is a chance of overflow due to increased rainfall. So we have different scenarios, and you can load, you can connect recent and real-time data and make this assessment. This was an interesting exercise that we did for emergency situation. This tool essentially is a digital twin, connects with real data, but also with water quality data. It's a virtual copy of the system, and it allows us to run both hydraulic and quality what-if scenarios to assess, for instance, what is a possible source of contamination in an event. In this lake over here, how is a possible contaminant going to spread, and after how long, and also what is the impact to the population of the city if we take an action, if we close certain valves, or change some, make some modifications in water quality. Again, on water quality, another digital twin that is being built right now as part of the Into-DBP project is a digital twin for disinfection by products. And this is essentially, it models reactions between disinfectants and other organic substances to estimate in real time, but also in a long-term span, what are the concentrations of disinfection byproducts. These are substances that are associated sometimes with carcinogenic diseases. Now, what's under the hood? Already Roberto showed a lot of things. So let me just, give you this bird's eye view in practice. So at basic, to do all of this that I have showed, we need to have access to data. So these are data spaces. We need open data, satellite data. These are very important. We need good geospatial data. Also, we need connection with IoT and SCADA data. So all of these should go to this digital twin backend infrastructure. And these should be connected with models. And here we're talking about computational models, machine learning models, and estimation algorithms. And also we need to have simulation engines and other type of algorithms that we are using. Of course, we need to use computational infrastructure, HPCs, GPUs, whatever, etc. And in the end here, we develop applications. So these are the type of systems that I have showed, but also it could be agents that are right now communicate with these backends and make decisions. So this is the next step that we will be working on. At the same time, digital twins do not work in vacuum. They sometimes produce an information that needs to be communicated with other digital twins and with other possible agents. So this part over here is very much related with the ideation project that also Roberto described. This is the type of architecture that we have developed at GEOS. So we actually have this system up and running. I will not go into the details. It's just the whole workflow from the data to the collection to the warehouse that manage the data to the digital twin infrastructure and the human machine interfaces. And very, very quickly, I'm going to do you a demo now, a video of our system that we have developed in Cyprus for local digital twins. So this is a Cyprus digital twin. It is not only for water, but actually you can see that it captures different types of systems. And this is the interface where we will select, for instance, here we will select a network, and we will try to assess the scenario of creating a new building block. So I'm just going to create, we estimate the demand of this building block and some minimum pressure and maximum pressure requirements that we need to have. And we have it there. So now it's running in the background. Now we can proceed. We can do some other, I'm just going to skip this for the sake of time. I'm going to go here. I'm going to go here to 30. So at the data, you can see that we already have almost 118 data sets. These are, again, these are data coming from many different sources, geospatial data, satellite data, meteorological data, anything else that we can, Earth observation data, etc. So essentially, these are our own internal data space that we have. And you can see the different layers. All of these, they relate with water. So it's not just, so for instance, here you see the pumping stations. We can have the dams, the floods, etc. So all of these are stored here. And we have APIs for this. So this is essentially what Roberto was showing. Essentially, you can see them more or less here. And let's see the result of the analysis. So this is the analysis has finished. And we see that if the development happens in the location where we set it, all of these nodes will be affected. But mainly we're interested in the blue nodes because this means that these people will get low pressure and the quality of service will be diminished. So the next steps, how everything is connected with Earth observation, digital twins, the connected digital twins. So we have digital twins now that model the Earth. We have destination Earth, which is a prime example of this. We have the digital twin oceans. And based on this information, combining satellite information and other type of information, we get different type of information that fits different type of digital models for groundwater, for reservoirs, for snow, in the end for the rivers, but also for these digital airborne water twins. So this is the whole future. And in conclusion, we saw that our experience shows that these digital twins can have a transformative impact on the regional water organization. The modular architecture seems to work best because it allows us to be more flexible across different organizations. We see that there is a multiplier effect for other investments. So digital smart meters, for example, is not just for billing, but it's for real-time estimation in digital twins which can be used for leakage, for pressure control, etc. So there's a clear justification why to install, why to make these investments. At the same time, the challenge is that the utility staff needs to have new skills and capabilities which are not part of the traditional academic experience. So we really need to bring this on board. At the same time, having these digital twins is critical, especially in the case of emergencies, because this is when you need to make decisions very, very fast. So this is added value. In conclusion, integrating space technologies and remote sensing together with the digital twins will give us an opportunity for these integrated digital twins that can support us in addressing water management holistically. And with this, I conclude my presentation.
Thank you very much, Dimitris. I will now give the floor to Ivana Barizin.
Hello. Yeah, let me share my screen. I hope you can see this. I'll put that now in.
Yes, we can see it.
Yeah. Okay. Good morning, everybody. Thank you so much, Water Europe, to let us present what we do here in Harwell. And I think we heard a lot recently how Earth observation is very important to the digital twins, but also for the water intelligence. So I will be presenting the work that 3 companies that are based in Harwell, UK, work closely. So we have Nanolize Technologies, Amelia Space, and Thermotors, who I'm the CEO. We have been recently just funded by STFC, Science and Technology Facility Council here in the UK. So this is a quick agenda. I will be covering in this talk, just to highlight the importance and usage of the Earth observation, but together with machine learning techniques, which are now integral part of that sector, and how that, when it's combined, becomes a very powerful tool for water sector. So we'll just go quickly through what are the advantages of the Earth observation. I think it's important for the user to understand what kind of data we are working with and what we're using, and what are the applications and few case studies that we have been working on. And quickly on a specialist insight, what comes out of these case studies, but also a quick word on this Mosaic project that our 3 companies are working together. It's important to highlight that the platform, or some call it maybe a digital film twin, but we are just really building a platform which integrates various Earth observation data and multiple data sources from satellites and drones, which can then give customers across the water industries ways of improving their water management. I think this is just a quick, again, a slide shows the importance of water crisis, what happens when we have a water crisis, and how this is now over the years, this water crisis has been increasing, and when you look at the global economic damages, the numbers are staggering. And when we just look at the natural disasters, they are mostly water related. So that's why it's important to look at the water in a holistic way. I think for the Earth observation in the water sector, I think the benefits are many. So I think we're all aware that working with the sensors in the field, it's timely, it's costly, and not always safe. And then real-time monitoring with frequent revisits using satellite data avoids that laborious work that comes with working with the sensors directly. We also tend to, satellite data tends to have a full spatial coverage. So you're looking at once and the entire asset, entire catchment area. It's consistent. So when you're looking at the satellite data, you will be getting comparable measurements across geography. Using it, the nature of Earth observation is remote, so you don't need to go there. You can just work remotely, and this type of data, it allows you then to scale from local operations to national programs. It's probably, it doesn't really have to be highlighted, but it can be automated where the reporting and trend analysis will come using machine learning, using the mathematical and statistical analysis in terms of time series. Those reporting can, when it's automated, it will in a very almost in real time give you the data necessary for management. I thought it was very important that we go through what the satellite data is used in these studies and in these case studies. So we can, I think there's a huge, if we know that there are over 1,000 satellites just orbiting the Earth for the Earth observation, they come in civil, commercial, defense. They're covering, but there is almost like a jungle of these satellites. Each satellite has its own purpose, but what we taking approach here is the agnostic approach. So by combining data from various of these satellites and knowing what each satellite is capable of doing, then we actually unleash that the power of the intelligence using the Earth observation and satellite data. So we go from optical data, which can come in form of panchromatic, so black and white, or RGB, which is color images, so which is showing us different colors, different shapes, vegetation cover. But we know that the drawback of the optical data is that when we have a cloud or in the dark, we can't work with that. Then we have a multispectral and hyperspectral type of data, which comes, which can then differentiate between vegetation types of water quality, soil type, especially when we talk about hyperspectral data that detects very subtle differences between the material on the ground, which then allows us to measure, say, stress in vegetation, chemical composition in soil, and so on. We work with thermal, infrared, and infrared. Again, very useful for mapping water stress or urban heat islands. So there are lots of applications just using thermal radar, which is very important to us as it captures topography, soil moisture, and also can penetrate through the clouds. It's a very, very important data set. We also work, there is a GNSS, which it doesn't cover large areas because it works like a GPS, so it's a point data set, but it allows, again, to calibrate the other data sets. So you can see there is a plethora of these different types of data, and when we start fusing them, then we have. This is one of the products we've been working on. It's soil moisture, so it's not something that's directly visible from, say, one data set. So we know that, say, radar data, SAR data, which comes from the satellite, detects directly soil moisture, but not in that it's in a way convoluted with the other signals. So we're using machine learning, we're using sensors on the ground, which give us absolute values in order to then process the SAR data in a way that we can extract the soil moisture. So on the left, there is an image of an area in Canada where we've worked with the SAR data, but not only that, but we also embed other geospatial data sets, which we know that are helpful in order to remove signals that might come from the vegetation or from the temperature and so on. So the working with different geospatial data sets then give us some results and products such as soil moisture, which are not direct. It is directly observed, but because it's a very noisy and comes up with a very difficult, challenging ways. We also done a similar study here in the UK for a farm, which measures soil moisture in these locations that are numbered. But as you can see, these are just direct measurements on one location rather than across the farm. The Earth observation gives us that breadth that we can then understand what the differences in soil moisture across each field, across the farm, which then allow, for instance, in agriculture, how best to manage the water, the irrigation scheduling, and how also that is then how the water or soil moisture is then correlated with the other nutrients in the soil. The Earth observation allows you to map the floods. So for instance, this is an example from Oxfordshire a few years ago when we had a huge flood here. So on the left, you can see just before the floods what the coverage of water body looked like, and then on the right, what happened in December that year. And because we're working with radar data, which penetrates through the cloud, it will allow that. Then it allows you to monitor that water spread in almost real time. Well, when I say real time, SAR data and open source data for Europe that's available. It's probably weekly, but that's also getting better. So, so the highlight here is to work on good models, good machine models with accurate data, and to produce the results that are robust. And when they go into these very complicated systems, they have to stand the accuracy tests and so on. We do create water quality maps as well by combining hyperspectral and multispectral images, which I've mentioned at the beginning, because they allow then to map individual water sediment or chlorophyll or other water indicators that show the how the water can be managed better. So again on the left, we use the hyperspectral data from the drone, and you can see on this river that by looking at the top image, you really wouldn't be able to see what's going on in the water. But if you look at the bottom image, we were able to classify different areas of water quality. On the right, there are a couple studies we've done for New Zealand for measuring the sediments in these two lakes. We also look at the water quality in Northern Ireland for a lake and for algae blooms. So they're caused by nutrient and agricultural runoffs. They cause tracking. So tracking and predicting algae blooms. It's not just taking it by hand. You now look at the holistic water, the entire water body at the same time, rather than just collecting data from the coastline. We think another very good, interesting application that comes from the Earth observation is this combining the SAR, so radar images, in order to follow the subsidence perhaps caused by the big groundwater extraction. So these are two examples of two big cities. Well, on the left is a Mexico City, and on the right is the Tehran. And they both show a substantial subsidence caused by the groundwater extraction. So it's really another use of this Earth observation is perhaps to employ when these digital twins are being built. We are also building a platform which integrates different data sets from satellites, airborne and drone data, so anything that comes remotely from, as I said, different types of satellite data, in order then to allow the user or water company in their needs to make those decisions in their management. So this agnostic integration of Earth observation data leads to more accurate monitoring systems. So it could be improvements for flooding system, it could be water quality monitoring for pollution and the pollution transport along these rivers, water bodies, or seas. We were looking at the agriculture waste resource monitoring or drought monitoring systems. Everything that has that link with the water, this type of data, Earth observation data, is very useful. So these systems allow for accurate calculations of for the environment systems, but equally they use for risk assessment and financial decision making, because then it will give you a better information, more intelligent information to assess those risks. Our Mosaic project, which we working on the SDFC funding, involves nanolized technologies, which are they're giving us a very good understanding what's happening in the nutrients and the chemicals of the water and the soil. Terra Motors is working on this Earth observation measurement, if you like, because all that Earth observation that gives us is in a way a direct measurement of what we want to observe. And then Amelia Space is integrating that all data into a decision-making tool. So we've been working with lots of partners, and we are actually actively looking for partners and customers, but we've already been talking to potential customers in the UK, Germany, and the US. And we also feel that a lot of companies, when they start looking how to adopt this technology, it can be quite daunting task, and therefore we feel that our expertise can also help in those companies to start understanding what is all involved when such technology needs to be adopted in their workflows. Okay, thank you very much. That's me.
Thanks a lot, Ivana, for your great presentation. I will now give the floor to our last speaker, Beatrice Barresi, who will present us an overview of the ESA BUS program, which is the Business Applications and the Space Solutions program. I will share.
Thank you. Thanks a lot. And yes, thank you, Anais. And I think that's the advantage of being the last speaker. A lot of things I've already said by my colleagues. So usually, one of the first challenges that I have to solve in a webinar like that is to answer the question how water is related to space, or how fishing is related to space. I think by now, thanks to the excellent presentation given by Dimitris, Roberto, and Ivana, you got practical examples of how this connection works and actually how water can benefit from space, even if the two sectors look quite distant, also, let's say, physically. But I will try in my presentation to put all things in context, giving a bit of inspiration how space can be used to achieve even more. And I will also perhaps give you some hints how these projects that we had so far, or maybe others in which you are involved right now, can be scaled, can be brought to an operational level, using also the support and the collaboration with the European Space Agency. So let's start maybe with the next slide. I just want to tell you a bit about ESA. So that's the European Space Agency. It was founded 50 years ago, and the objective, let's say, in the constitution of ESA, the objective is to create a gateway to space for supporting European companies to exploit space data, space technologies only for peaceful purposes. Unfortunately, nowadays I have to make this clarification. So that was really, let's say, the aim of ESA when it was founded. We have 23 member states. You see the flags here in this slide. Again, it's important to say, because sometimes there are confusion about which countries are eligible to work with us. So here you have a complete picture. Of course, then we have associated members and one long-standing cooperative state, which is Canada. If we go to the next one, we will see, yes, all the areas where ESA is active. We are proud to say that among all the space agencies in the world, ESA, so the European one, is the only one which covers basically all the areas of applications related to space. So we do have teams here in ESA working on designing, launching, operating satellites, which is maybe the most known, let's say, area of expertise if you think about an European Space Agency. But that's the program where I work, BAS. We do also take care of understanding how those capabilities that we develop in space can be used for the benefits of us, of citizens, of our economy, of our society down to Earth. And you have seen with water, but actually, if you look at the whole plethora of applications that are unlocked by space, you will be surprised. We are often unaware users of space, but almost every day, either, I mean, if we operate in agriculture, in transport, in energy, a lot of these solutions are enabled by space. As agency, we have developed more than 100 satellites. We have also our, let's say, spaceport in Kourou, in French Guiana, so we are able also to launch satellites from there. If we go to the next one, where we are located. So we have 8 sites across Europe. Myself, I'm based in Estec in the Netherlands, but actually spent a few years in Exat, in the campus that Ivana was mentioning before in the UK. Then we have a site where our headquarters is in Paris. We have sites in Germany, in Spain, and so on. So we try to cover, you know, a bit more or less all Europe. We are more than 2,500 people working for the agency, and we have an overall budget of over 8 billion euros. This budget has been allocated to us, to our programs last November. There was this ministerial conference, which is a very important high-level meetings where all the member states of ESA come together and decide the budget that is going to be spent for the next 3 years. And this was quite a remarkable result. It has been the first time over the 50 years of ESA that we have received such high budget. So it's really, let's say, important for us, because this budget then can be used by us to help and support the European competitiveness. If we go to the next one. So just to be a bit on the gloomy side, unfortunately, as we know, we live what's called the triple planetary crisis, which means that we are living the climate change. We know the effect of the climate change are visible, unfortunately, every day. This brings also biodiversity loss and environmental degradation. The crisis, unfortunately, is not only, let's say, of environmental nature, but eventually it impacts also our economy, it impacts our society, it impacts the way how we live, the way how we eat, the way how we operate. So given the fact that there is this crisis, given the fact that there are challenges that we are facing, we need to find solutions for these challenges. And my message here is that space can be part of the solution. Technology, digitalization, innovation can be part of the solution. I was in a panel yesterday, and someone said, I think it's really true, innovation, digitalization is not the end, is not the goal, but it should be an enabler, a mean to develop solutions which solve some of these challenges. So I think that should be also something that we have in our mind when we think about solution. Don't do that just for the sake of innovating, but having clear in mind what is the objective, what is the need, what is the challenges that we are trying to solve. If we go to the next slide. I just want to give a bit of overview about the space capabilities. Already Ivana was quite complete in the overview of the different capability of the Earth observation. This just to say that we are not short when it comes to Earth observation data. Now you can see from the different icons in this slide that there are different type of sensors flying over our head that can provide data. Thanks. I mean, we have to be grateful for that. Data of different nature, of different capabilities, they cover different bandwidths and so on, because they can be used for different applications. Of course, also meteorological data are part of the Earth observation images, so often we don't realize that, but all the information that we have about weather, they are also coming from satellites. And the other good thing to consider is that these satellites, many of them have been flying or somehow we have been active in this sector since, I would say, more than 20 years. And this is very important to build what we call time series images, time series analysis. So if we want to predict the future, now Dimitris was talking a lot about digital twin, what if scenarios and so on. So to create this simulation, we need to understand what has happened in the past. And having this long history of satellites, it's really helpful. This just, let's say, part of the Earth observation satellites. This what you see here. There are already a lot, but that's what ESA operates. But of course, on top of that, you have satellites coming from other space agencies, and you have also commercial satellites. And as it was said before, we should be agnostic when it comes to data integration. So we should not be focusing too much on who provides the data, but we really have to start again from the challenge that we want to solve, the problem that we want to solve, and going backwards, understanding which kind of data we need, without starting now from the technology, let's say. Next one is just to see how those data can be then used in different applications. We heard about flood risk. We heard about quality monitoring of the quality of the water. Of course, you can also monitor the quality of the air. They can be used for vegetation monitoring, so to know how healthy are our plants, our vegetation. They can be used to do population density, so to look at the urbanization also affect how the landscape of our cities are going to be modified. They can be used to monitor the temperature, so to make the famous urban heat maps, which again are important when it comes to cities and also to some water-related events. So again, that's just an overview to tell you how these EO data, Earth observation data, can be used then in specific applications. If we go to the next one, we see that space is not only about Earth observation. I just want to make you aware that when we consider space-based data, when we consider solution enabled by space, we should not limit ourselves only to Earth observation, because the richness and the added value really comes when you integrate data from different resources. And I would like to provide you some examples, some practical example. We heard before about how important was to use IoT sensors, for instance, no? Because they need to monitor, for instance, the pressure of the water along the pipeline and so on. Well, when you display IoT sensors, somehow you collect the data that they measure, and you need to know from where this data they have been monitored. To do that, you need to rely on satellite navigation, because that's the only, let's say, technologies that allows you to synchronize your information, but also to have accurate information on the positioning. So that's, I mean, it's we didn't discuss with Dimitris in advance, but I think it's a practical example to show how, again, we were unaware of using a space asset, in this case, space navigation. But let's make another example. So let's say that instead of Cyprus, because I don't know how is the terrestrial connection there, we were, for instance, in some cities of Italy. We don't have to go to Africa, it's a very remote location. Even UK, because I said I live there, and sometimes using the phone was not the best solution. If you need to transmit data, sometimes the only way to do that in a reliable and robust way is to use satellite communication, because there is no alternative. Or for instance, if there is a flood, if there is an emergency, we know that the first thing that is going to be overloaded and not working, not functioning anymore, are our terrestrial coverage. Again, satellite communication means transmit data over satellite. That's an example of how we can use space-based capabilities, in this case, not coming from Earth observation, but which are, let's say, fit to the purpose, which in this case is the data transmission. Next slide. One slide, okay, I work in ESA for this program, which is called BUS, which is an acronym which stands for Business Applications and Space Solutions. I realize there is a typo in space, but basically our objective is to help European companies in taking all these advantages, all these solutions that are enabled by space, together with other technologies, in order to provide services for different segments. These segments can be as many as possible. So as I said before, thanks to space, we can improve and we can provide better solutions for agriculture, energy, transport, urban scenario, water, of course, healthcare, and so on. So it's very wide, the range of applications that can be unlocked, and it's very wide if you consider the space capability as a whole. That's why you have all these blue icons to tell you that talking about space, we should talk about observation, navigation, communication, even human space flight and space weather, because we should not limit ourselves in neither think about the technology or the provider, I would say. So we really have to combine and integrate the data in different ways, because it's there only at this point that you unlock solutions. And in BUS, we believe that by doing that, you as a company can become more competitive. You can provide a service which is with better performance, which means that you eventually as a company can also grow economically, because you are going to provide a solution which nobody else does it, or maybe you do it in a better way, in a more performing way. Going to the next. We had made an analysis internally in BUS just to see what the kind of results that the program was delivering, the so-called socioeconomic outcomes, because we think there is no best way to demonstrate the impact of a program by looking at the numbers. And okay, here you have different numbers. The slides will be shared afterwards. But I just want to pick on few elements. First of all, we have seen that companies working with us generate revenue. That's the basic thing. And actually, the pie that you see at the middle, in the center, it means that companies start selling already during the project, during the BUS project, which is a very important result, because they don't need to wait until, couple of years after the conclusion of the project, but actually are able to sell and to provide, to generate revenue already during the ESA activity. Then, of course, this means that they are able to create jobs, to create partnership, to export, so to go to other countries and so on. Because our program is, of course, only for the member states of visa, if you remember the slide with the flags, but the market, the customers that they are going to benefit from this solution can be anywhere in the world. So even export is something that we consider and we appreciate a lot for our companies. Going to the next slide. Profitability is important, so we want to make sure that our companies generate revenue, sell, create jobs, all the things that I said before. But of course, they have to do it in a way which is sustainable also for our planet and for our society. So in the same way as we monitor the performance of the companies that work with us in terms of economic impact, we also monitor them when it comes to health, let's say, for our planet and for the people. In the case of the societal benefits, we use the SDGs, so the development goals which have been defined by UN. When it comes to the environmental benefits, we look at the green KPIs that have been defined according to the areas, let's say, of the areas where the service is deployed. So the message here is doing something good for the profit, but also for the planet and for the people. Going to the next one. What's the benefit for the companies that work with us? So by working together, so that's again, it's maybe a call for action. If you have done a project so far and you want to see how it's possible to scale that or to have it, let's say, bring it to an operational level, then you might consider working and apply to the BUS program. By doing that, you will receive funding. So we are a co-funded program of the European Space Agency, means that we let's say we co-fund the cost of the project. The rate of co-funding, we will see a bit later in the slides how much it is, because it depends on the type of the activity that we consider. By working with us, you will receive, of course, the ESA logo. So you can say that you have a contract with ESA. And that's really important, for instance, if you're looking for third-party investors or for partners. The IPR will stay with you because, again, we want to support the commercialization of the solution. So this will stay with you. And by working with us, there will be a person of the team, it's called a technical officer, which is going to go and guide you through the different steps of all the activities. When I say different steps, I mean both technical and commercial aspects. So for us in BUS, both, let's say, elements are of equal importance. So we want to make sure that a company running a project with us do develop the technical solution, but also consider the business model to make sure that once the project is finished, the company has reached a very good level of maturity, also from a commercial point of view, so they can go and sell in the market. To the next slide. I just want to introduce very quickly the concept of the Bioeconomy Task Force, because we are glad to have Water Europe as one of the members. Because of the nature of the diversity of solutions that we support, of course, us being the European Space Agency, we cannot be expert in water, in energy, in transport, and so on. So we are really glad to establish partnership like the one that we have done with Water Europe, because these partners allow us to understand what are the priorities, what are the needs, what are the challenges in that specific sector. We work together to identify what will be the opportunities for both, let's say, network. In the case of water, we have Water Europe as part of the Bioeconomy Task Force, which is a task force which basically has the objective of promoting the utilization of natural resources in a sustainable way, in a sustainable manner. If we go to the next slide, you see a bit what are the areas of expertise that are covered in the Bioeconomy Task Force. There are various because there are different ones. So we have agriculture, of course, forestry, textile, and water. Going to the next, because I'm also thinking about the time. When it comes to water, just want to say that we have a number of partnership and collaboration going on, of course, with Water Europe, but we have also the Water Resilience Coalition, the Sea Water Mandate, OFWAT, which is operating in the UK when it comes to the water sector, DEWA in Dubai, and GWOPA, which is a part of the UN Habitat for promoting the water and the sanitation of the water operators. Going to the next. The next 3 slides, I will go very quickly. These are just examples of solutions that have already applied to us, and they have developed operational solution. What it means is that if you Google Aquascope in this case, you will find a solution which is up and running. So if you want, you know, if you're a water operator, so you are interested, you can contact the company and perhaps buy it or make a kind of partnership. This kind of solution is focusing on monitoring and forecasting the water quality, has been developed with food and water operators. So for instance, Nestlé and Anglian Water are already customers of this solution. If we go to the next one, you will see another example. In this case, this solution has been developed by a German company. Again, it's based on providing an overview of the water quality of inland, but using a different technologies. The funny thing that you see in the picture is a kind of floating platform where they have installed some IoT sensors that are used to complement the data coming from space to have more accurate information about the water quality. Again, you see the advantage of integrating data of different type. In this case, earth observation with in situ sensors. The next example comes from Zoe, and this is pretty much a solution which has been developed to monitor leakage along the water network. Sometimes, as we know, the pipeline can be aged, there could be problems. There is a lot of money that are lost because of the so-called non-revenue water. And what we have seen that thanks to this solution, this has been decreased by 60%. Next slide. So we have already with Water Europe, with Andrea and I, we have already, let's say, defined what could be concretely something that we could do together. So we put forward this proposal of a call for proposal on digitalization of the water sector. This call is going to be open second Q2 of this year, and it will be to develop solutions using space, of course, and other technologies to address all the challenges related to water sustainability and water resilience. Sustainability, you know the subject better than me. It can include different topics. We have water quality monitoring, availability, sanitation, industrial discharges, and so on. When it comes to water resilience, this means including all the failure of the network, climate adaptation in the sense of drought and flooding effect, and so on. The call will be open, as I said, from Q2 of this year, and that will be an excellent opportunity if you want to apply, for instance, and doing a kind of follow-up handover between what you have developed already, for instance, in the Living Lab or in the projects that we had so far, and giving them a chance to scale and to add the elements which are perhaps missing or which needs to be developed further to make it really operational. Next slide. Maybe we can skip this one. Sorry. Yes, so I just want to have 1 minute to discuss on the funding scheme, because I'm sure that will raise some question. So this call that I mentioned before, it will be for proof of concept and pilot project. The main difference between these two family of activities is the maturity of the idea that you are putting forward. If you want to verify the technical suitability and the business case of your solution, starting from, let's say, just an idea, then it's best to go as a proof of concept. Whereas if you have already developed a kind of pre-operational way that you know there is an MVP, a proof of concept has been already done. You know that the solution from a technical point of view works. There is indeed a clear use case of space, that there is a potential interest from the customer, then the best way is going to pilot project. So I want to say you don't have to go, through all the phases. If you, because of the collaboration with Water Europe or other, internal research, have already developed something which has a concrete basis, you could apply directly as a pilot project. And in this ugly table, you see what's the level of funding that will apply according to the nature also of the activity that you want to do, so either being proof of concept study or pilot project, but also according to the nature of the company, of the entity that you are. This call, in general, all the bus calls are open to any kind of entity. So you can be an SME, you can be a corporate, you can be a research institute, you can be a university, but of course the level of funding will change. And what is important from us is that in the team, so you can be a single entity or you can be a consortium, so in a team, we need to identify who is going to be the so-called service provider. So it must be within the consortium, within the team, an entity that will be in charge of providing the solution to the customer once that it becomes operational. Okay, next slide. I think that's my last one. I just want to invite all of you to come to ESTEC here in the Netherlands, to the ISA premises. We are going to host an event on the 12th of May. Of course, also Water Europe will be our guest as well. The agenda, all the information for the registration and so on are on our website. There you find the link. The agenda is still a work in progress, but I can spoil to you that, of course, Water Europe will also be among our speakers. The registration is for free, so there is nothing to pay, but sorry, the attendance is for free, but the registration is required. So if you are interested, please go to the website, register, and then if you have questions, you can always contact me. And I think with this one, I conclude my part, unless there are other slides, but I don't think so. So thanks a lot, and I think we can open directly the floor for questions. And I thought there were some messages in the chat, but I didn't have the opportunity to go through them.
Patricia, many thanks. I mean, I think, not I guess, I think that we have turned quite a big stone of interest around the bus program and the opportunities that can be exploited in terms of pilots and proof of concept. And I also think that, I mean, this is a great opportunity really for pushing and enhancing the capacity of the world stakeholders, I mean, to have access, I mean, to the space services, and that we have seen that they are not just Earth observations. From the audience, I've seen that there are questions. Some of them have been already answered by some of the panelists. I find another one, which is about the question about, under the umbrella of digitalization, the topic of cybersecurity, it is surely a concern. And then there is, I mean, a reference to the CIA regulation under the EAC 62443. And the question is, what is the level of security that water utilities are demanding to comply? I don't know who is, I mean, the best speaker, I mean, to answer to this, or we might send them, I mean, this question, I mean, to water utilities, but I don't know whether, I mean,
maybe I can just take it from, let's say, a data point of view, because of course I'm not familiar myself with this regulation. But what I can say, if the concern is about cybersecurity, I think you can understand. Okay, we didn't have the time to go through the different options, but blockchain, for instance, is a way that is based on satellites to make your data more robust and with less chance to be tampered, modified, and so on. So that could be a solution, for instance, to use this kind of technologies to make then the information more robust.
Any other contribution from the other speakers on this topic? I mean, how they see cybersecurity?
Maybe just a quick comment from my side. I think it's a very broad issue, and I think the IEC standard that is mentioned, it focuses on the industrial automation part. So this is I think there is no at the moment a complete solution. I think right now there is a gap here. I think most of the utilities are transitioning now from having just a very closely knitted SCADA system to open up the system, to open up their data by adding more and more IoT sensors and smart meters, and everything goes through the cloud. So it's a totally different architecture from what they're used to. So I would say that it's not a problem that has been solved. I would say it's a challenge that needs to be solved in parallel with everything, because we cannot afford to delay the modernization of the water systems. But at the same time, we cannot dare think of the exposure of these systems that they will have due to the security risks. And of course, we want more and more data. But I would say it's critical. It's not a problem that, at least from my point of view, I think there is still a lot of work to be done, both in research and in the industry, especially in the areas that are close to the physical system.
Yes, and just to complement, even though I am not an expert, but in terms of security levels foreseen, the standards, I guess, let's say for the water utilities, we are moving at least from security level 2 up to security level 4. These are the level of security that in the water sector we should consider.
Any other contribution? Because today, I mean, we really went through a lot of topics and discovered, I mean, a lot of opportunities and horizons, I mean, concerning space services. I don't know, Beatrice, if you want me to add.
Yeah, no, that's indeed. I think, as you said, it's a lot of digest, right? Because there were a lot of information presented. So I was just typing on the chat my email address, because maybe it could happen that attendees afterwards, after they go through the slides, they have some more questions, so they don't hesitate to contact me. I think the clear message that we want to pass here, Andrea, correct me if I'm wrong, is that there is this, we have established a partnership, a collaboration between the two agencies, and now we have to make sure that all our members benefit at the most. And what we can offer is now, I was impressed when Andrea presented to me for the first time the work that you have been doing with the Living Lab and the many activities that we support. Among those, if any of you has an interest of building up what has been done, understanding if space can be a role, or maybe you are using already space, as we have heard before, and you want to scale them to bring them at, let's say, the next level, the pre-operational level, BUS could be a way to do that. And we can see together what's the best way, if it's a response to a call, but of course there are different instruments that we can offer. Yeah, just get in touch with me and we see together what will be the best way. We have Kickstarter. The program is very flexible. There are different instruments according to also the maturity of the day of the idea that you want to propose.
Yes, also because I mean this webinar for us is just a starting point,
Exactly.
Because we can also organize, I mean, I don't say bilaterals, but we can organize also, I mean, restricted sessions, I mean, for interested stakeholders by categories. Also, this can also be done. But for sure, I mean, I think that there is one important takeaway today is that, I mean, it is important that we move beyond the pilots and isolate the use cases, and we go, I mean, on a broad perspective. Because I mean, we have the opportunity of really, I mean, through the demonstration activities, the Living Labs, as you said, and that the real operational context is really are essential to test the solution, and then I mean to go to the market to take the solution and the deployment of solutions. And well, I mean, I was already convinced of the matter that the value of space based data for the water sector is not really, it wasn't theoretical. I mean, so it's really practical. So, I mean, it is not only a matter of contribution to monitoring, planning, and the decision-making system that can be offered, I mean, to the space-based data, but it's really an approach. It's really a system that can really change, I mean, the capacity of the territories in being more efficient in the water management. Also, in the perspective of the main driver from the European Commission for the water sector, which is represented by the water resilience strategy and what will come after that. Something else I would like, I mean, to add. I know that we are a bit out beyond the schedule. I mean, but just a few seconds. I mean, to pre-announce the matter that Water Europe is organizing in April, on the 16th of April, Water Market Europe 2026, which will be focused on digital twins and data management. And there will be another opportunity for reconnect also with the European Space Agency on the BAS program during this event, which is a brokerage event in order to put together problem owners and solution providers and to find, I mean, the way for better for a practical and tangible collaboration. I don't know if there is any other comments, I mean, to this to the webinar today.
There's a question, Andrea, regarding the link for the registration.
For what the market?
Sorry, for the recording of the webinar.
Yes, I mean, everything will be shared, I mean, including the presentations and the post-event communication from our side.
And indeed, I mean, I thank you for the organization. Thanks a lot, because that for us it's an excellent opportunity to go to a broader network to pass the message. And as Andrea was saying, we are very open to also organize one-to-one meetings. Maybe we have face-to-face conversations. So don't hesitate to reach us out, because we are very eager to collaborate, to work together. Yes, and Canada, please, you as you have seen, there is your flag there as well. So we are very eager to start a new activity there as well. So don't be shy. Thank you then from my side. Thanks a lot.
It's been a big pleasure. Thank you, all the speakers. Thank you, Beatrice. Thank you, the European Space Agency, for this, I mean, great opportunity. We will keep on working with according, I mean, to our memorandum of understanding and beyond that, for sure, because I mean, there are a lot of opportunities that can be taken, I mean, immediately this year. And well, I mean, we can close, I mean, the webinar. Many thanks, I mean, to all the speakers, Roberto, Dimitris, Beatrice, Ivana, and I think also Alan, who participated, I mean, in the pool. And thank you, Anais, for the great support for this session. And once again, see you soon, I mean, on the topic that we discussed today, maybe from a more even practical point of view for the stakeholders of the water and water in the sectors. Thank you once again. Thank you.
Thank you very much.
Thank you.
Bye.
Bye.
Have a nice day.
Bye.